Okay, so today we're going to talk about complex numbers, and specifically imaginary numbers, okay? So an imaginary number, it comes to address a problem when you have a math problem that you can't solve. For example, let's give a little example right here. Let's say we have x squared plus 1 equals 0, and we're trying to solve this factor, okay? So I go through, I can't do the difference of squares because it's addition, but I go and start solving it. I get x squared equals -1, which means that x equals plus or minus, remember if you take the square root of both sides, you do plus or minus, the square root of -1. Okay, now we have a problem here. What is the square root of -1? Now, normally when you take the square root of a number, you would say, okay, what two numbers can I multiply together to get the number underneath the radical? Okay, so 4. Let's say I have a square root of 4. Do it down here. Example would be that the square root of 4, because you can take and multiply 2 times 2, the same number by itself, that is the square root of that number, right? So the square root of 4 is 2 because you can multiply by itself. Well, the problem is if the number underneath the radical is negative, there is no way in your knowledge of numbers to take two numbers that are multiplied together to give you a negative, right? Because if you take -1 times -1, you get a +1. So if they're both negative, it becomes positive. If they're both positive, it stays positive. The only way that you know out of regular numbers without imaginary would be to multiply a negative and a positive together. Well, then that's not the same number. So that's by definition of a radical you can't find. So that's where we introduce I. Okay, the square root of -1 is I. So then here, this would become x equals the plus or minus I, okay? And I is this imaginary number. Okay, so let's look at how we use I and how we write it. That's not a cute color. Let's see if we can get a better blue here that's just a little different. Okay, so imaginary numbers come in the form A plus BI. Okay, where A and B are real numbers. Okay, so those are imaginary numbers and complex. I'm going to write imaginary here so you guys can. Imaginary. This is why I should use my text and not my mouse to try and write words. Imaginary numbers. Okay, you got that. Okay, so A plus BI. A and B are real numbers. So let's look at some examples of some real numbers that you know that are still considered complex. For instance, the number 3. The number 3 could be considered 3 plus 0i, meaning that there's no I component. You would multiply that by 0. Okay? Now, or you could have something like 5 plus 2i. Okay, and that's what we're going to be dealing with now is these values that come in this form, this A plus BI form. Okay, and we're going to be changing, manipulating them. Now, I want you to take note that it you treat it a little bit like you would a quadratic. Okay, and in that sense that I terms are like terms and constant terms are like terms. Okay, so when we start working with these more and start combining them and things, it's not the same as like having 5x or 2x, because you have to treat I with the rules of I, but it does have like terms within I. Okay. Okay, so something I want to add here is that if you take I squared, that equals -1. Okay, so as you're changing things, if you square your I, you're able to change that and substitute that in for -1. Okay, so these are kind of the main points that you need with your notes to do the assignment. Okay, so naturally, the quadratic formula brings up complex numbers. Okay, and what's the quadratic formula? You guys all know and love the quadratic formula, right? Let's get another color here. So x equals -b. Here, let's write it down. I gotta get my, oh no, I want this, and I want a pen. Here we go. X equals -b, pressing it super slow because I can't write very fast. Plus or minus square root b squared minus 4ac all over 2a. Okay, so we've been working on finding these zeros for polynomials. Now, sometimes the zeros that will come are imaginary zeros. And what that means visually for the graph is that it doesn't cross the x-axis, but it still curves. So for instance, if a quadratic is way up here, it still has two roots. They're just both imaginary roots because they don't actually cross this axis, okay? So, and we'll talk more about that as we go through. But anyway, if this, how you know if a quadratic has imaginary roots would be if this value is less than 0. So when we've been calculating them right now, you can assume that you've done something wrong if there's a negative under the radical because we hadn't worked with imaginary numbers yet. But now it's going to open up this world where it can have a negative number underneath the radical, and that would just mean that your roots are imaginary. Okay, so let's make sure and add that. If b squared minus 4ac is less than 0, then there are imaginary roots, okay? And like I said, we'll go a lot more into detail with that. Anyway, so there are imaginary roots if that happens. Okay, so let's look at now how we can treat these. We're going to look at adding them and multiplying them. So first of all, adding imaginary numbers. Like I talked to you about earlier, is they have like terms. So if this were going to be a situation that that you're adding these, you would take, if it was bx and dx, you would add those two together and add the constants together. So this is the same way. So you would take your a plus your c. We'll do numbers too. We have to kind of talk through the math language of it, and then we'll do the numbers as well. And then over here, you would add your b and your d, and that would still be multiplied by I. Okay, so let's do a little example that actually holds those values. Let's see really quickly. Okay, so let's take an example with numbers. Let's take the 3 plus 2i plus 5 plus 4i. Okay, so we're adding these two together. Now, when you're adding them, remember, they're like terms. So you look for your like terms to add together. You add your 3 and your 5, so you get 8. Plus, I'm going to add together my imaginary terms. I have a 2i and a 4i, which gives me a 6i. Okay, very similar to adding first degree polynomials or any polynomials with common like terms. Okay, so now what happens if we are subtracting? All the same things. You just need to be extremely careful that you are distributing your negatives correctly. So for instance, and you can even have negatives in between here. So let's do 3 minus 2i. Okay, so here, anytime there's a set of parentheses and you're subtracting something, you have to subtract both of these. So what you're actually doing is 4 plus 7i, and you're going to distribute that negative to both, minus 3, and then negative and a negative, this becomes a positive 2i. So depending on what those signs are, you're going to distribute those throughout. Then here you can combine your like terms. You have 4 minus 3 gives you 1, and a 7i plus 2i gives you a 9i. Okay, so treat it a lot like you do your quadratic. So it shouldn't be too hard to do that adding. If you remember, just combine your like terms. Okay, so now let's talk about multiplying imaginary numbers. So if you have an imaginary number a plus bi and you're multiplying it by c plus di, you have to FOIL out. Okay, now we've talked about this with quadratics and with even just the first degree polynomials when you multiply them together. You can't just multiply the a and c and the b and d because these are multiplied by each other. The addition sign connects them. Okay, it's the same rules. This a plus bi is connected. It has to stay together. This has to stay together. The only way to combine them is to FOIL. First times first, outer times outer, inner times inner, last times last. So all of this practice that you've been doing on quadratics and creating quadratics and factoring them is all, it's going to build upon that now with imaginary numbers as well. Okay, so let's look at an example with actual numbers. Okay, so looking at this example, we would have to take and multiply everything else. So we have first times first is 6 okay, from our 3 times 2. Then we take 3 times 6x. Now this works the same way as when you multiply by 6x. I did say 6x, 6i. You get 3 times 6i is equal to 18i. Okay, you multiply the two numbers together and the I comes. Okay, and then we have inner times inner. 4i times 2 is 8i. Okay, works exactly the same way as if you have an x there. Okay, and even when you come here, you get 4i times 6i, which is 24i squared. Okay, now we wrote something down on the first notes that was really important. Let's write it down right here again. I squared equals -1. This is going to help tremendously to simplify these imaginary terms, right? So that you can have things simplify down. Okay, so here what that means is that you have 6 and this becomes a -24. Okay, so the 6 and the -24, so we're going to add those two together. 6 minus 24, remember we're adding like terms, so it's adding. 6 minus 24, because this is -1, this whole thing becomes a -24, we get -18. 18i plus 8 is what, 26? If I do my math wrong, you guys, I'm sure, will tell me after. Sometimes when I'm talking and writing. So we get -18 plus 26i. Okay, great. So we are able to simplify that down to a single term that way. Okay, so what about if we get something like this? 2 minus 3i squared. Okay, same thing. You cannot just distribute a squared in to something that has an addition or subtraction in there. This actually has to be multiplied out as 2 minus 3i times 2 minus 3i. And you have to use the good old FOIL. Okay, and you're also going to have to use this x squared term. So you'll have 4 minus 6i minus 6i. That's a 6i on that first one, if you can't tell. And then you'll have the last times last, which will give you a positive 9i squared, which I squared is -1. So then you'll combine your like terms and you'll get 4 minus 9 is a -5 and minus a 12i. Okay. The last thing, I guess I'll just show you a quick example as well of maybe I times 5 minus 7i. Okay, this works the same way. You can distribute a value outside if there's only one without an addition sign, just into each one. So you'd have 5i minus 7i squared. Remember, what does I squared equal? Ding, ding, ding. I squared equals -1. So every time you see I squared, you have to think, oh, I squared equals -1. So you can simplify that in. So we have, this becomes a positive 7, and we would write that first because the form that we write them in is the whole real number. And then we would have plus 5i. Okay, so this becomes a positive 7 because I squared is equal to -1. So if you want to see that here too, let me make sure that this is making sense. You have 5i minus 7 times -1. Okay, and that's where the positive 7 comes from. So then you have positive 7 plus 5i. Okay. All right, so this is kind of the first part we're focusing on, and then we'll get further in and do some other things with imaginary numbers. But what I want you to focus on right now is remembering this. I want you to remember that I squared is equal to -1, and remember to treat it like terms. You can combine i's, you can add them, and don't forget your FOIL rules that you need to multiply out, your algebra rules that you have to distribute your negative. All of these rules still apply. You just now have this one other rule, and you're dealing